3 tutorial of the web application. The web application. So this is lesson 3 tutorial. So what we're going to do here is that we're going to build our models, right? And then set up our database configuration and then migrate our models down to the MySQL, which we'll be using here in this class, right? So now this is the MySQL Workbench you should be using in this class. So let me just delete this so that I'll do this from afresh. So drop. Okay. So let me just delete this out. So if I refresh, okay. So if I refresh, it should be out of here. Okay. So let me just cancel this so you understand what we're trying to do here. Okay, so let's start. So if we go to our lesson here, the lesson 3 is the Object Relational Mapper. So now what is Object Relational Mapper? An Object Relational Mapper is a programming tool that allows developers to interact with a relational database using the object-oriented paradigm of their preferred programming language. Right, so the programming language, high-level programming language we're using here is Python, which if you don't understand this, well, there's no way you can understand this if you don't watch the lesson 1 and lesson 2 tutorial, right, so that you can be able to follow up what we have been doing ever since. So here, instead of writing the SQL queries directly to manipulate data in a database, developers can work with classes and objects that represent database tables and rows, right? So now you can see the advantage of Object Relational Mapper. With the aid of this, we can actually map your object to any relational database management system. And the relational database management systems are the popular ones we have currently in this country are the Microsoft SQL Server, the MySQL, the Oracle, the PostgreSQL. These are the common ones we have. So if you can choose to use anyone in this tutorial, right? But here in my own tutorial, I'll be using the MySQL Workbench because it's free and open source. Despite other ones have student edition, right? So let's just work with the MySQL because um, it has advantages when it wants to host this application, this flagship application to um, a shared hosting platform. So it's by default you can actually find MySQL present almost everywhere, right? But MySQL and Microsoft SQL Server is somehow restricted to some shared platform. Also Oracle, also PostgreSQL to some shared platform. So that's why we're using the MySQL because it's actually presented in almost all shared platform. Because at the end we are hosting this application, right? So now let's look at the database. We all know that basically database has to do with how we can be able to store our data, modify our data, and retrieve our data efficiently, right? And these are the type of databases that we have here. So our core focus is the relational database management system, right? The relational database management system, right? So now if you don't have the MySQL installed on your system, all you just need to do is to type the download MySQL Workbench. You can see download MySQL Workbench when you click on enter. So the second line here, you're going to click download SQL Workbench here. So once you click on this, it will open this. All you just need to do is to select your OS that you're using, right? So mine is Windows, right? So then click on download page. It will take you to there where you can download it. So we have the Windows x86 32 MS installer. So this is about 306 MB. So this installer will work on x64 bit. So you can download this and definitely to install, right? The installation is just straightforward. Now let's move on. So now I am in my Visual Studio, right? So let me cancel this. So this is my global init.py. Remember that we created modules in our previous classes, right? So this is my global init.py. Like I said before, if you don't understand this class, you can't understand this class if you don't refer back, if you don't watch the lesson 1 and the lesson 2 video of this course, right? So now this is my global init.py where we set up our factory function and then this function that um, navigate to the index.html, which is our base HTML page. And this is my blueprints for all the files, for the faculty file and department file, this is where I register them. So where's the blueprint for the modules, right? So now this is where we will set up our connection, right? So the first thing we need to do here is to go to a new terminal, You click on terminal, you click on new terminal. So it pops up here. So the first thing we need to do, you can see that the virtual environment is not actually activated by default, but there are some systems where the virtual environment is activated by default, right? So we have the env, that is the name of my virtual environment, then scripts, then activate, right? So there are things we need. We need the driver, we need the MySQL driver, we need the Flask Migrate extension too. I also need the Flask SQL Alchemy extension too. So I'll explain. So to install that, we pip install the PyMySQL. So this is the driver that makes the connection to your MySQL database. So now we need to install the Flask Migrate. So this extension tool allows us to easily migrate our objects directly to the Microsoft SQL Workbench that we're using, right? So it works alongside with this, right? So then we need the Flask SQL Alchemy. You can see I was spelling it all our lowercase. So the Flask SQL Alchemy contains the Relational Mapper that will aid us to do the data manipulation here, whereby for each lesson, assume that for faculty, where we want to insert record into the faculty, we want to delete record from the faculty, we want to update record to the faculty table, or want to delete all record, or want to select from that particular faculty. That is the functions which we need, which are all in here, right? So I'll click on enter. So everything here installed, they are all installed, right? They're all in my virtual environment, so I'm good to go. So I will go to my global init.py. So the first thing I will need to do is to call from Flask SQL Alchemy, right? So import from Flask SQL Alchemy, import the SQL Alchemy. Right? So I have to initialize this, right? So I have to, let me call it a variable. So I have to call this is SQL Alchemy, right? So I've initialized this and I've assigned it to a variable called DB, right? So the next thing I need to do here is to import the Flask migrate, then import the migrate, right? So I have to do the same thing to migrate. Let's call the variable name migrate and let's pass the function migrate, right? So you can see I've actually called the DBLSK Academy and done this, right? So before we move further, let's go back to our slide. So we all know what database is. We all know the type of database, and now we are using the relational database management system here. And now we all know that relational database management system is actually made up of tables and the relations here. Eh? So which I've explained in the last class, right? You can see each table known as relation. So represent a specific data entity. So now we use this table in the last class to explain how the table, we use it to explain how this works. So now you can see this ID and student name. They are called the columns, or you can call them attributes, and these define the characteristics of this table. Now you see the number one John and this Peter, these are rows, or you can call them tuples, right? So before we move further designing our model, you need to understand critical things, the constraints and the relations. The constraints and the relations, right? So now what is a constraint? So constraints are rules we apply to a column or set of columns in a database table to enforce data integrity, accuracy, and consistency. Now we have some very type of constraints, but in this practical, what we'll just be looking at here is just the primary key constraint, the unique key constraints, the foreign key constraints, and the not null. This is what we just explained here in this class. When we'll be completing the application, definitely we'll apply this in some instances, right? So, but I'll just explain these for now. But these are basically one of the key ones we actually use when creating our models, right? Then we still use this one when we want to like get the default time or date at which a record is being created. But I will just keep these two for now, right? Now, what is a primary key constraint? A primary key constraint has to do with is a unique identifier. Unique identifier. Right? Now, by default, it does not take null value. Does not take null value. Does not take null value. right? And we can only have one primary key constraint in a table. We can only have one primary key constraint in a table, but we can have a combination of one or more attributes, two or more attributes, right? Combined in a primary key constraint, which becomes what's the composite primary key. Then the unique key is similar to the primary key. It's also a unique identifier, but by default, the unique key takes no value. Right? By default, the unique key takes no value. And we can have more than one unique key constraint in a table. So now we can only create relationship when we have the foreign key and the primary key. So foreign key is a key that is referencing a primary key in another table. So this is what we do. The relationship are created when you have a primary key. Then if you have a foreign key here, that is the foreign key is referencing a primary key. That's only when you create relationship between two or more tables. Right? So foreign key here takes duplicate values, right? It takes duplicate values. But that value must exist in the primary key where the that value must exist in a column declared as a primary key in another table. Let's give an example. So let me just go to now you can see here we have a faculty table here. So the faculty table has attributes which are the ID, code, name, and date created. So this makes use of the default constraint. Right? This makes of the default constraint, right? So now you can see the expansion. You can see the expansion of the. You can see the expansion of the table, the faculty table, right? So you can see that ID one. Remember, this ID is already enforced to be the primary key, right? So this doesn't take duplicate value by default. So now we have the faculty code COM and the name is computing. This is the default date to which this computing was created. So you can see natural and applied science NAS, which the ID is 2, right? Can you see that? Now if you go to the department table, if you go to the department table, you will know that every department belongs to a particular faculty, right? So you can see that computer science and software engineering belongs to a faculty ID that bears 1. So in this place here, this faculty ID here, which is the attribute here, is a foreign key, FK, is a foreign key, right? So you can see that the value 1 exists here. The value 1 exists here. So and the value 1 here is computing. So it means that computer science here belongs to computing faculty. Software engineering department here belongs to computing faculty. Because we have enforced this foreign key rule to this place here, right? To this place here. If I put an ID that doesn't exist in the primary key, it will not take it, right? It will not take it. Let's say if I put 3 here, what the system does, is it goes here and check there's actually 3 here, right? That means computing, that means this one will fall under medicine. But what if I put 5? So if I put 5 here, it will not take it because there's no ID 5 in the primary key table, so it will reject it. So that is the advantage of linking up this relationship between these two tables, right? So now we call this relationship one-to-many relationship, right? One-to-many relationship because you can have many departments to one faculty, right? Because you can see the faculty has a primary key which is unique, and the department table has a foreign key which takes duplicates, so it becomes one-to-many, right? So you can actually make it one-to-one if you just want to have one department to belong to one faculty, but that doesn't make sense, right? But you can have one staff to one office, and that becomes one-to-one relationship, right? But that will only be enforced. I'll show you guys when we start the practical, right? So now you guys have understood what foreign key is, you have understood what primary key is, you have understood the difference between a primary key and unique key, you have understood the difference between a primary key and a composite primary key, right? So now what we need to do now, the last thing you need to know is the relationship, which I've explained, the one-to-many relationship. You can see this is a sign of one and this is a sign for many. You can see one-to-many, the department table and the faculty table. Now, I will explain this many-to-many relationship. For instance, when we have many students to many courses, these are actually many-to-many relationship. The one-to-one relationship, we'll see that here, right? We'll see that in the practical. So now you guys have understood the theory part. So let's continue with our practical. So we have already installed our relational database management system, which is a MySQL Workbench. We have installed the SQL Academy, which have we have installed the Flask Migrate and the Power MySQL driver. So now, I've already done this import. I've already imported the SQL Academy. I've already imported the Flask Migrate. So I've already initialized the SQL Academy and I've already created an instance of the SQL Academy and assigned it to a variable, which is DB, right? Which is DB. So I already created the Flask Migrate. I've already created the instance for Migrate and assigned it to the variable, which is called the Migrate. So the next thing to do here, this is not the next. The next thing to do here is to set up our connections. So I will go to the stuff here. So now I have my DB, I will hide a variable, let's call it DB user. So if you are using the MySQL, the DB user by default is called the root. So I have my DB password. Now I don't want to put my password here to be visible. What I did was just to create my a password of pi that is returning my password, right? So all I just need to do is to call the function, right? That's how we say the function has to do with a block of visible code, right? That allows you to perform specific tasks. So you can see the function is written here to return my password, right? It's a simple function, just to return password. So what I will need to do is to import, to call it from app, that is the app folder, right? Dot the script is called password, right? So import get password, or you can just say import this. So this imports everything here, but it's just one function I wrote there. So get password. So I'll pass it to this place here. So it means that this DB password is holding what is returning here, right? So I have my DB host. So since the SQL is on my local machine and you're using MySQL by default, it's localhost lowercase like this. So I have my DB name. Okay, now this DB name will have to go to the MySQL Workbench. So I will go to my MySQL Workbench. I'll click on it. So I'll click on my localhost. Remember that the password you put here must be the same password you are passing to that your Flask framework, right? So I'll write my password here. So I'll click OK. That's open. So for the sake of your practical, even if you don't want to do yours like this, you can actually do it like this. I'm passing that your MySQL password inside this, right? Inside this, it will work, right? So okay, so now let's create our database. So you can see we have opened up a new script, right? So these are our schemas. So what we do is to create database, then let's call it student course group, right? Okay, group, not group. So I will highlight this and then click this. So it has created here, although it won't show you until I click on this icon to refresh, you can see it here, student course group. So what I'll do, I'll copy the name of this database here and then paste it inside this DB name here. So you can see, so I've passed my root to DB user, then this is my password, I've passed the local host to DB host, and then pass this to DB name. So the next thing to do here is actually to set this up on my factory function, right? So that it can be able to recognize this our particular app here in the factory function here. So all I need to do is the variable, right, dot the init app, then I'll pass the app itself, right? This app, I'll pass it here, right? So we have my migrate does the init app. So I'll pass the app and I also pass the DB because we're trying to the DB is what we're trying to migrate, right? So that's why I'm initializing them here, right? So we have done that. So I will set up my connection now where within the Apache function I can have my database URI, right? URI is I, capital letter I, right? So I will have my string here, but you need to put a format because we are passing that value. So if you fail to put this, it will actually see the value within the string here. So I have my driver, MySQL plus The driver is called MySQL, right? Then this, then I have this, which is the DB user at first. So then this, then the DB password, then this at DB host, then this DB name. Okay, so now I have to pass this variable because this variable now DB variable is holding the connection string, right? It's holding the connection string. So I have to pass this connection string to the app.config in the Flask framework. So I have to pass it here, which is app.config, which I will call. Remember, they already downloaded the SQL Alchemy, so I will call it SQL Alchemy, right? Like this, capital letter like this, SQL Alchemy database like this, URI. Remember, it should be I, not L. URI, capital letter I. So I'll pass it here, database URI. So the next one is app.config, right? Where I will have my SQL Alchemy track modifications which becomes false for now because we don't want to track any modification when we're doing the data manipulating here. So let for now it be false. Okay, I think we are done with the connection, right? We're done with the connection. So the next thing to do here, let me just put it in the last place here. So with app context, right? With app context. So db.creator. So what this does is when we define our model, because in this class I'm not going to define all the models, you guys will do that as part of a task. You guys will complete the models apart from the authentication module. Now what we're going to do, we're going to create a model for faculty and department because once we do that, you can be able to do all, right? Because the faculty, the department has a foreign key, and once you understand how to link up the foreign key with the faculty model, you can be able to do all because almost all they all have foreign keys, right? Referencing a particular tables here. So so what this does is it creates new objects. It helps us to migrate new objects to the relational database management system, which is a MySQL we're using. So it checks if the object already exists, it won't actually create a new one, right? If the object exists, it won't create a new one. But if the object doesn't exist, it will create a new one, right? And migrate it. And you create the new object, which is being specified here, and then migrate it automatically to the uh, relational database management system. That's what this function does, right? So now the next thing to do here is to define our models. We have set this up, right? So I will go to the faculty module now. Remember, we have the models apart here. We have the models apart. So what I'll do now is to import the from app import db. So db was the variable that stores that will pass the SQL Alchemy to, right? So that's what we're calling it here. Remember, it was assigned in the global init.py. So now I will create my class for the faculty, class faculty, right? So I'll pass the parameter db the model. So now I will have my table name double underscore like this, table name, and double underscore like this two times. Then the name of the table is called the faculty table. So I'll have my attributes now or my column, which is ID, right? So I have my db dot column. Then the data type for this will be integer, right? So I'll declare my primary key lowercase like this equal to true. So by default, it won't take no value. So by default, what it does is when you're inserting record into this faculty table, it auto increments this ID, right, by default. So the next thing to do here is to write our name, faculty name, which I have my db.column. So db is a string. So the character length should be, if I have the faculty of computing, let's make the character length 50, so it's not be more than 50. So that means what this means is that the character length will not exceed 50, right? So that is equal to 50 or less than 50, right? So anything outside 50, it will return an error. So I'll have my nullable. I don't want it to be false. I want it, okay, nullable false. I want it to be false so that it will not take a null value. Then I want it to be unique. You can see I want it to be unique, which is true. Now, can you see how many constraints do I apply here? I've applied the primary key constraint, I've applied the not null constraint, and also applied the unique key constraint in this particular table. Right. So now I will have my code, which I have db.column. So I have my db.string. Now code character length should be more than 10, right? I have my nullable, which is false, then have my unique, which is true. You can see why we said we can have more than one unique key constraint in the table. You can see we have two constraints here, two unique key constraints in this faculty table. Do you see that? So now I think we're done with the faculty table, right? So all I just need, let me just create um, this for log. This is actually not necessary, but just for logging and debugging sake, so that we actually know which table is being affected when we're trying to, in case there's an error, right? So to return format, so let's put faculty. So this is self dot let's use name. So I have to fetch out the name in case there's an error, right? So that's why I've done this. So you can see that I've done this, right? So I don't need to rewrite this in the department table. I'll just copy this. So I will go to the department module, right? Then the models of pi, I'll click on it and I'll paste this. Then I'll just change the name. So I'll change this name to department. I'll change this name to department. So I'll change this table. I'll change this table to department, right? So I will change this one to department. So self.name, so there's a name attribute here, so it's done. So the only thing I will have here is a foreign key because every department belongs to a particular faculty. So I'll have my faculty ID, then have my db.column, so which is db.integer. It must be of the same data type with the one declared as the primary key in the faculty table. All right. So db.foreign, foreign key, right? So now the foreign key here, the name of the database, the name of the table is faculty table, right? Faculty dot, then the key is ID. The key is ID. So I will put nullable equal false. It means that this faculty, even if we were declared that this, so it won't take null value, right? To take null value. Now, in the case of one-to-one, like if I don't want two departments to belong to one faculty, like if I don't want it, this is where I will now I will now like manually enforce it here by using what? By using the unique, which becomes true, right? It means that if a particular department belongs to a faculty, right? You can't actually use that foreign key again here for another department. It doesn't make sense, right? But that is just an example of one-to-one relationship, right? So, but here it doesn't actually make sense. So remove it. So you can see I'm done with this, right? I'm done with our tables. So the last thing we'll do here is to import our model. So import this model on the global ini.py, right? So I will import this model here. Let me just comment on it. Import the model. So it's from the app folder dot the faculty folder dot the model script. So import faculty, right? So why is this showing error? Where's the error coming from? Okay. Okay, please. So from app dot, where's the error coming from? Let me do it here. From app dot faculty dot models import faculty. Okay. Then from app dot department dot models import import department. So I've successfully import my model, import models. So I'll successfully import my models. So the next last thing I'll do now is to run this. You can see how I've set it up, right? You can see how easy it is, right? So now the next thing we do is to go to my terminal here and then type the flags db, because db is the variable that holds the configuration of the database configuration, right? So the database setup, sorry. So db init, I'm going like initially flags db init. Right? If I click on this, okay, it's giving me error. So what will be the error here? Okay, SQL binds must be set. Okay, let's check what we are missing here. SQL database URL, right? So dot config SQL Alchemy URL. So what are we missing here? Okay, sorry, we need to initialize this before the configuration. Right, need to initialize this first. So let me do it again. Okay. What make the error is that we call, you know that Python is a makes it an interpreter. So it's executing this, then before executing this. So that's what's the error. So you can see that I brought this down. So when it checks the correct connection, right? So it then pass it here, right? So you can see. Now if you notice here, there's a folder that has been created here called migration. You can see this folder automatically it has created here called migration here, right? You can see that. So now next thing I will do now is to do the flags db migrate, right? Okay, flags db migrate dash m. So let's put a name, let's put any name, let's put initial and click enter. So now you can see it has migrated all my models. So if you go to the MySQL here, and this is the student course group, right? So if I refresh this, so if I open this, now you see my tables now, department and faculty, they are all migrated to this relational database management system, which is in MySQL, right? So now the last thing I was just going to do is FluxDB upgrade. So this is what you'll be doing, right? So when you create another model, what you just need to do, right? So let's assume, let me just create one more. Let me just create for program so that you see what I want to do now. So if I go to the department, right, I'll just copy this. So you go to the program, every program belongs to a particular department, right? So I'll just go to the program models of pi. So I'll paste this here. So I will change this. So I will change this to program. So I will change this to program. Now I will change this to department ID because the department ID is a foreign key. So it's referencing department table, then the ID, which is the primary key. Then everything becomes the same, right? So I'll change this to program. Right? So you can see what happens here. So let's confirm if this table name department is the same thing what we have here. So if this is my department, yes, it's the same. So you can see it didn't even take me up to 1 minute to finish my program table, right? So because most of the things we're doing here is just copy and paste once you define the first one. So now this is the the global init.py. So when I click on it, all I just need to do is to import the program now from the program, right? Dot models import program, right? So now I'll perform the same process here. I'll start by doing the flags db init, which is not actually necessary, just perform, right? It already exists. Then the flags db migrate dash m. Then the name. Let me just call this name. Let me call it program, right? So I click on enter and it's already there, right? So as we migrate, so just then for update, fast DB upgrade, it's already there. So if you go to the SQL now, once you refresh this, you should be able to see program here. So once I refresh this, you can see this is the table program, right? So if you want to find out how it works, right, we can actually use a select and data manipulation language here, which I can, let's probably use this. So select from program. So you can see our table created, right? Can you see our table created? That's why I said we'll naturally be using the raw SQL to create these codes. You can see what we did here, and that's what we're doing all through this class, right? So I hope you understand this. If you have any question, feel free to ask me on the comment section. I'm always there to answer you. Thank you, and God bless you.